Hello and welcome. In this video, we are going to take another look at our Matlab numeric vectors or numeric one-dimensional arrays. This video is part of a larger series of videos that focuses on the construction and access of elements in a vector. And again, we're going to use those two terms interchangeably, vector being considered a one-dimensional array. In Matlab, we're also going to look at row and column vectors. Now, specifically in this video, what we're going to do is we're going to look at two functions, the length function and the size function. I'll give you a little bit of an introduction to them, and I guess you could say sort of the dangers of not knowing the difference between the two. Now, again, this is going to come up in later videos in this series as well, but what we're going to do is we're going to start off with a basic Matlab vector. It doesn't really matter how we create it. We could create it manually. We could use the colon notation, or we could use one of our functions. But in this case, I'm just going to go ahead and stick with the colon notation. And I'm going to start off by creating a vector that starts at 10, counts down by 1, and then stops at 0. And so we know from an earlier video that this should create then a 1 by 11 vector of doubles. And then what we're going to do is we're actually going to go ahead and leverage that A vector, and we are going to create then a column vector using the transpose of A. So what this should result in then is going to be a 11 by 1, again, a vector of doubles. Now, the particular values in this vector doesn't really matter. Again, you could use any of the built-in MATLAB functions as well to do this. But the idea is that I sort of want us to get comfortable with the idea of the orientation of this vector. In other words, whether it's a row vector or a column vector. So let's go ahead and run these two lines. You'll notice that I've intentionally left off the semicolon here again so that we have a little bit of noise in our command window. And you can also come down here and just simply type in the letter A as well as the letter B. And again, I want to emphasize these are absolutely terrible variable names, but I'm just trying to keep this example simple. Now, the idea here is we want to understand the difference between the length function and the size function. And to do that, I'm going to go ahead and pull up the help using F1. If you're not familiar with the help, I encourage you to get into the habit of just simply pulling this up on any new function that you are using, or as well as for a reminder of the functionality. And so the length function does kind of what it sounds like it's supposed to do. It returns the length of the largest array dimension. And that's the critical thing with the length function. Regardless of how many dimensions your array is, in this case, we're going to be dealing with vectors, it is always going to return the largest array dimension. Now, again, we're going to talk about these functions later on, but in this particular example, hopefully you could start to see the problem early on. And that what I will do here is I will simply specify the length of A. And while that doesn't seem all that surprising, the length of A should in fact be 11. Now, where does the problem come in? Well, in this case, if I do the length of B, which remember is the transpose of A, well, that is also 11. Now, since these are vectors, and in this case, one is a row vector and one is a column vector, it doesn't really matter because essentially all we have is a sequence of values in this particular case, or a collection of values. Perhaps they aren't ordered or anything like that. But fundamentally, it doesn't really matter because that other dimension is a 1. In other words, basically it's 1 in length for the number of rows and 1 in length, or 1 in the number of columns. So again, it doesn't really matter too much when we're dealing with vectors. However, though, it is sometimes useful to get both dimensions, and this is where the size comes in. And again, I'm going to pull up the help real quick for the size. And very succinctly, it just specifies the array size. And more specifically, what it does is it specifies the length in every dimension of the array. Now, again, we're dealing with vectors, so this is going to seem a little strange here, but we would like to at least look at what the size of A represents. You'll notice that I get two values back. In other words, I specify both the number of rows and the number of columns. And if I do the size of B, likewise, I get two values. First, the number of rows, and then the number of columns. And the thing to notice here is with vectors, Or just conceptually with arrays in general, you want to think of the first dimension as rows, second dimension as columns. Beyond that, we'll talk about some decisions that you can make with how you want to represent your data. But for now, we want to look at the values for these vectors, or the dimensionality for these vectors. So the A is a 1 by 11, B is an 11 by 1. Now, the last thing I want to show you here is that you can technically capture the return value from both the length and the size vectors. And so what we can do here is I'll use sort of a generic variable here called results that you might fit in to some later script, but we can just simply say the results are going to be equal to the length of A. And then sure enough, you end up getting a new variable here that has just a single value of 11. And you can see up here in the workspace, there are the results and the value is 11. And again, all of these are of type double. Specifically, the length will also return a double. If we use the size, in other words, if we say that results are equal to the size of A, you get what you might consider a rather peculiar return value. In other words, you get another vector. And this seems a little strange here because, yes, the size function is operating on a vector, but because it returns multiple values, it actually returns them as a vector itself. In other words, it's a 1 by 2 vector. And so this is going to be a 1 by 2 vector of doubles that specifies the size or the length in each dimension. Let me slide my help out of the way here so I can add a little more to my comment. And so this is a vector of doubles that is the length in each dimension. And we can do the same thing now with saying the results are equal to the size of B. Now, before we lose perspective here, remember that B is the transpose of A. And so remember that that is supposed to be an 11 by 1 column vector. And so you would expect, again, 2 dimensions. And so, again, you get a 1 by 2 vector of doubles. And in this case, it specifies that the 11, or the first value, is the number of rows, and the second value, 1, is the number of columns. And again, you should go through these examples multiple times to make sure you're comfortable with this. Let me go ahead and get, again, the help out of the way here so you can see my workspace. And take a second to verify that this actually makes sense to you. Now, one last thing I want to show you is that, technically speaking, then you can leverage this in a couple of different ways. First of all, you can actually access each individual element in this results vector. And so results, parentheses 1, will simply give you the 11, which will be known then as the number of rows, and results, parentheses 2, will give you the number of columns. And again, we're going to play around this more when we start looking at multidimensional arrays and how you would extend that, for instance, to describing maybe layers in an image, or layers in some other data set multidimensional array. Then the last thing I want to point out, and this is going to seem kind of a little bit comical or even a little bit confusing, so don't let it bother you too much if you don't completely understand this, but we can actually turn around and take the length of our results, and guess what that will tell us? That will simply tell us then the number of dimensions in our vector or array. And so this will actually be the number of dimensions in our array or vector. And remember that essentially a vector is nothing more than a one-dimensional array, but technically speaking, there are 2 dimensions, because if it's a row vector, there's technically 1 row by n number of columns. And if it's a column vector, it's n number of rows with 1 column. So hopefully this video was helpful in at least starting to understand why it is useful to use both the length and the size functions in different applications. We will definitely be using these again in later videos. So as always, hopefully you found this video useful. If you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.